Hi, everyone. Thank you for joining us today for this Agentic AI workshop. Um, Georgia is here with me. Don, unfortunately, had some business travel, so he will not be able to join us today, but he did record his sections, so you'll be able to uh, hear him speak anyway. Yes, thank you for joining us. The goal of this workshop is to give you an overview of Agentic AI. What is it? What can we do with it? And also, what can you code on your own? In fact, it's quite easy to get started, and we'll have some hands-on exercises today where we'll be coding our own agents. So we're going to, first of all, be talking about what is agentic AI. Let's define it. Um, it Sometimes it's loosely defined. It's a bit of a marketing buzzword these days. So a lot of different companies will say that they have agentic products, but what does it mean really in practice to have an agentic workflow? And we're going to watch a recording by Don where he will explain what agentic AI really is and what qualifies as agentic AI. Then we'll go through a notebook, a hands-on exercise, and I'll take you through uh, basically how to build an agent from scratch. So we'll do some direct orchestration. We'll build an agent entirely from scratch for a demo application. And then Georgia will take over and she'll talk about MCP servers and agentic frameworks. So how can we use modern technologies and modern frameworks to avoid writing a lot of the boilerplate code and getting ready for, say, a demo in very little time. And then at the end, we'll circle back to Don and he will tell us about a more advanced use case of agentic AI, which is coding agents. Some of you might have used GitHub Copilot or OpenAI Codex or Claude. Agentic tools that help you code faster. We'll see how we can build such a tool actually from scratch. And Don will be walking us through that. Yes, so the material of this workshop is not necessarily strictly related to the Agentic AI hackathon. It was just convenient for us to schedule them around the same time so that if you are planning to participate in the hackathon starting tomorrow, you can use the resources of the workshop as a reference to get started. But there's definitely a lot of overlap in material, but there might not be complete overlap. Okay. So we will get started talking about what is agentic AI. I'm going to play a video that was recorded by Don. Please let me know if you have any trouble hearing it.
Okay. Hello, everyone. Sorry I can't be there. I'm flying today, and so Marta and Georgia will take great care of you. But I wanted to record my pieces in video. Hopefully, this won't be too boring. So firstly, we thought we'd define the concept of an agentic workflow because since it's such a buzzword in our industry, a lot of vendors are just using the word agents and agentic for like everything. But there's a particular style of using AI that we're going to talk about in this session, which I'm calling an agentic workflow. And it usually has like these three components. Or at least two of the three components. So the first is multi-step workflows. So to get whatever it is we're trying to get done, you usually have multiple calls to the LLM. So there's multiple steps that need to happen leveraging the LLM in each step. So it's not that single one shot that we're kind of used to. The second is this concept of tool calling. So the LLM can call tools which do something. So up until now, LLMs just kind of write you an answer to a question or write a poem or whatever you ask an LLM to do, write code. But in this case, the LLMs can, call APIs, read databases, search the web, can affect change in the environment. And this makes them more powerful. There's some downsides to that, which we'll talk about. But in terms of leveraging AI, to get more power, more important things done, I guess, that affect change in the environment, in our systems, or in the systems in their world. That's what tool calling is all about. And the third is a non-deterministic workflow. So the LLM is kind of in charge of what happens next in these agentic workflows. And it's non-deterministic in that the LLM might go in directions that you didn't necessarily predefined. So it might be because of the results of a tool call, what it found on the web, or what it read from a database, or these sorts of things. It might do something different for the next step. So the LLM is sort of given the control over the workflow and decision making of what happens next. And so I think the best way to think about the word agentic is it derives from the word agency. So we're giving the Gen AI, the LLM agency in this case, to make decisions, to call tools, and this allows you to leverage AI in a different way than we've been used to. So I'm going to contrast this with RAG because probably many of you know the way RAG works. In a RAG system, retrieval augmented generation, your code might take a question from the user like, has this patient been in here before for a cardiac condition? You would drag information out of a database, a vectorized database like ours, that would be relevant to that user question. And then you provide this whole bolus of the prompt, any instructions, and all the context that you got from the vectorized database to the LLM and say, please answer this question given this context. The LLM has one shot, answers the question, and then you show it to the user. And so that's been the RAG approach that we've been using the last couple of years. In contrast, the agentic workflow works different. So in your case, you have your code, and you're calling the LLM, but you're not providing all the context in advance. You're providing the prompt, and you're providing a list of tools. So you might say, hey, the clinician wants to know, has this patient been in here before? And your list of tools is list the sections of the patient chart that the patient has, list the documents that are in the chart, and fetch a document by ID. Those are your three tools. Would you like to call any of those tools in order to answer the user question? The LLM would say, yes, please. Call the tool to, tell me all the information or the headings of the patient chart. And so you would call your tool. The tool would say, this patient has some problems, some meds, some labs, some allergies, some immunizations, and 25 documents. And so you'd bundle up the results of that tool. You'd capture that output. You'd send it back to the LLM, and you say, would you like to call another tool? I want you to answer this user's question. And said, yes, I'd like to see that discharge summary number 123. So fetch document 123. And it would request that tool to be called. You would fetch that document. You would get the output of the tool. You'd send it back to the LLM. Would you like another tool to be run? And it would keep going through this tool calling loop until the LLM feels like it's ready to answer that question. So that's how the agentic flow works, is that you're not providing the context in advance. You're providing a list of tools, and this whole flow will call those tools and send the results back to the LLM and ask the LLM what it would like to do next. So that's what this flow is all about. Now, to contrast it with RAG, I think there's two things I would mention at a high level. So one is RAG is faster. So in this case, you're using more tokens, you're doing more loops. It might be difficult to make this an interactive user experience. You can, but it takes longer to do this kind of flow. But on the positive side, it can handle one problem RAG has is that you will generally grab like the top 5 chunks from the vector database of information that is relevant to the user question, or top 15, or you'll have some hard-coded number based on your token limit of how much information you want to pull out. But let's say it's 5. So if I say, what are the cardiac history for this patient, you pull 5 good paragraphs and send that along with the user question. What about that 6th paragraph, that 6th document that referenced something important about the patient's cardiac history? So you're sort of predefining everything for one LLM call. But with this agentic approach, if the LLM wanted to dig further, one discharge summary might reference a visit 10 years ago, and the LLM might say, well, let me see the discharge summary for that one 10 years ago. And it can kind of dig the way us humans do through the information until we feel like we have enough to answer the question. So it's a little bit more flexible in the way it gathers context, in a sense. Second thing is, a RAG is kind of a read-only system. You're sort of answering the question. This can call tools. It can call APIs. It can schedule appointments. It can write emails to patients. It can, book slots in a schedule. It can fire off an prior authorization request. It can kind of get things done based on the user what the user requested the system get done. A RAG model is about answering questions and providing information. This can be used to get things done. And so we can kind of build more powerful workflows leveraging Gen AI with this kind of approach than just the RAG approach. Okay, now let me just give you the history of tool calls, because this whole thing is only about 1.5 years old, but it has an interesting little evolution. So you recall, like, if a user asked the question in ChatGPT, what is the current population of Boston? That these models still have a training cutoff date, so couldn't really answer current questions. But what we cleverly did, or somebody cleverly did, is they said, hey, I want you to answer this question, but I'm also providing you a tool. And the tool is a search. And if you want to use this tool, respond back in XML. Like, don't respond in natural language. Don't answer user's question. Just respond back in this XML format where you're requesting the search tool with the search query as an argument, and just write me that XML back. And so I would get that back in my code. I'd parse the XML. I'd call the tool that it requested, get an answer, and then call the LLM back and say, hey, I got you that, I did you that web search, I did the web search that you asked for. Here were the pages that came back, the information that came back in HTML or whatever. Try again. Can you answer the user question? And it would answer the question. And so the LLM response, just to back up one, would be something like this. So instead of writing a paragraph for natural language, it would write XML basically and request a search. And so this was kind of the first tool call, was asking it, instead of answering a question or writing something, to write XML. If you want a tool, go ahead and write XML. So LLM started to get good at writing XML and requesting tools. And they were trained as such. Now, frameworks came out like LangChain and LangGraph and stuff. It sort of hid some of this from you. That was kind of the next step, is you would just specify a tool and it would write the XML. It would parse the XML on the way back. It would call your tool, and it kind of hid this sort of XML, thing that got invented. And then eventually the vendors, Anthropic, OpenAI, and such, added tool calls into their API. So you can send text and you can send a list of tools, and the response back from the LLM can be a tool call request. Basically, very specific, I picked this tool, I want these arguments, type of thing. So we added tool calling into the API of these models. And this is all in the last 18 months. So this is kind of a quick concept, but it's a really important breakthrough in the way we use LLMs to do this tool calling thing, which really opened up this whole agentic model, which we'll teach you about, and we'll teach you about it now. So back to you, Marta.
Hopefully, most of you have done the homework for this class, which was a quick Colab notebook to get you ready for the Agentic AI workshop. And if you scroll all the way to the bottom of your homework, you'll see that there is a link to the next notebook. And the next notebook is where we're going to get started today. I'll actually paste that as well in the chat. Here it is, but you can also find it by clicking here on this next notebook. And you should find yourself here at the Colab notebook that says Creating an Agentic Shopping Assistant. Now, I will talk you through this notebook, guide you through the cells, and explain what the code does. And at the end of it, we'll leave 5 to 10 minutes of time for you to actually go through the notebook yourself. So if you feel like it's better for you to just listen the first time around, there will be more time in 20 minutes or so for you to actually run the code on your own. And what else? There will be a few cells in this notebook which have some placeholders that say, put your answer here. And that's just so you can try your hand at coding some of the logic in the notebook. If you don't want to if you don't want to do that hands-on exercise, you can always run this first hidden cell in the notebook, and that will automatically populate the answers for you. So it's going to be an easier way of going through the notebook if you don't want to do the hands-on exercise. Now, without further ado, let's get started with our implementation of an agent. Today, we are going to build an agentic shopping assistant that can add and remove things from a shopping cart based on what you want to buy at the grocery store. And we'll do this with a technique called direct orchestration. Direct orchestration means that we will be coding everything from scratch. There will be a little bit of boilerplate code that we need to put together, but it will really, I hope, give us an appreciation for how agents work under the hood. So what the entire logic is. And I think that's very helpful to understand, even if you eventually choose to use an agentic framework, because it really allows you to debug and optimize the underlying logic. So I'll go through this notebook, just pressing Shift-Enter through every cell. First of all, agents need access to a large language model. And you've already connected Colab to a large language model in your homework with the API keys that we provided. So I'll go ahead and run this first cell that just imports the API key into the notebook. And then imagine that we want to build this shopping assistant agent. And we have the following system prompt. You are a helpful assistant that adds and removes items from a shopping cart. You have access to tools that let you add grocery items, remove items, and inspect what is in the cart. So all the basics that you need to handle your shopping cart. Please do not ask any follow-up questions after I make a request. Just use the tools to satisfy my request. And this is just to keep things simple. We could definitely implement a solution with a human in the loop, but for the sake of this demo, we figured we can delegate all decisions to the agent and keep things simple. Is the text here big enough for you to read? Maybe a thumbs up?
Yes.
Okay, great, thank you. Okay, so we are telling the agent that we're providing these 3 tools. So let's actually create those 3 tools. We're going to start with an empty cart. And that for us is just an empty Python dictionary where we'll list all the items that we want to buy and the quantities. So if you're not familiar with Python, this is a list of key value pairs. And we have a tool to add items to the cart. And this is just a simple Python function that takes in a string, which is the item name, and the quantity as an integer, and adds it to our dictionary. So it's a very simple Python function, and we'll test it by calling the function and then seeing if it added something to our shopping cart. Here we are asking it to add 5 apples, and indeed, if we print out the shopping cart, it added 5 apples. Same thing for a tool to remove items. Again, a very simple Python function that removes items from the cart. We can go ahead and test it out. We asked it to remove from cart all apples, and it did so, and now we have an empty cart again. And then we have a tool to see what is in the cart, and this will just return the contents of our Python dictionary. There's no AI here. This is very plain Python, just 3 utility methods to interact with the cart. So now we are going to dive into the AI side of things. Before we do so, are there any questions about the setup of this demo? Okay, then it is time for some AI. A user is going to send the following prompt to your agent, which is, please add all the ingredients for fruit salad into my shopping cart. Now, what is the agent going to do? Well, first of all, the agent really has no reasoning capabilities. It has to rely on the LLM for all reasoning. Now, our LLM is on a cloud service, so I put it in here in a little cloud, but it could also be a locally hosted LLM. In any case, the agent will need to rely on the LLM for all reasoning. And it will also need to run the tools. In Agentic AI, the agent really is the middleman. It's the orchestrator of the whole agentic interaction. The LLM decides what to do. The tools actually perform the job. The agent just allows the LLM to interact with the tools, as I tried to explain in this diagram over here. I find that sometimes there's a bit of confusion between the agent and the LLM, a misunderstanding that the agent and the LLM are the same thing. They aren't. The LLM is just the large language model that provides the reasoning, and the agent is the agentic application, so the orchestrator of it all. So first of all, when we set up an agentic application and we get a user prompt, the very first thing we need to do is explain to the LLM what the user prompt is. So what is the task and what tools are available? And this is the very first step of any agentic workflow, just letting the LLM know what challenge it has to solve and what tools it has. And then the LLM might decide to call some tools. It will send the tool request to the agent, and then the agent will be the one who runs the tools, likely because the agent and the tools actually live on the same server. And so the agent has direct access to the tools. Then the agent will capture the outcome of the tools, and it will relay it over to the LLM. And then the LLM will decide, okay, do we need to call more tools or are we done? And the LLM will keep calling more tools until it's satisfied with the result. So in the next few cells of this notebook, we are going to look at this first communication, so explaining the task and tools to the LLM, and then we'll look at how the agent runs the tools. Before we move on, are there any questions about this diagram? Okay, no questions yet. If you can think of more questions later, feel free to put them in the chat, and we'll stop multiple times throughout the notebook to address them. Okay, so first step is explaining the task and tools to the LLM. In order to explain the task, we can just pass along the user prompt. To explain the tools, we need to pass in some structured information. So to get started, the agent needs to tell the LLM which tools are available, and it will do so with this object called tools. It's a list of 3 objects, and they each describe one of the tools that we have available. So let's just look at the first one. It says we have this method called add to cart. It takes in some parameters, which are the grocery item to be added and the quantity of the grocery item to be added. That's the same method that we imported just a few cells earlier. And this is important because the LLM needs this structured explanation to understand what tools it can call and how to call them. This is the format expected by OpenAI. Different providers with different APIs might expect slightly different formats. So if you're using Gemini or Anthropic, you might have to format this object a bit differently, but the core concept of it is always the same. And you'll see how the descriptions here are natural language descriptions, because this is what large language models understand. They understand the same language that we understand. So I'll go ahead and save this list of tool descriptions. And then if the LLM decides to run one of the tools, instead of responding with regular text, it will respond with a tool call object. That's very similar to that XML object that Don was showing earlier in the slides. This is, again, the structure that OpenAI expects for it. You can see that here we're setting a simple tool call object where we're going to add something to the cart. And once again, it's going to be 5 apples. We're sending the name of the tool we want to call and the arguments. And as the agent receives this tool call, it needs to process it. So the first thing it will do, and that's the code we need to write, is extract the tool name and the arguments from the tool call. So you don't need to worry about generating this tool call object. I just wrote down an example here for convenience, but this will come from the large language model. When your agent receives it, it needs to extract the tool name and the arguments, and it did so here, and it interpreted this request correctly. Now, this is a simple demo, so we're not going to put in a lot of guardrails. I'll be honest, both in terms of security, in terms of resource utilization. We can have a conversation afterwards about how we could make this more production ready. But this is really just a demo to demonstrate the capabilities of Agentic AI. However, there is one guardrail which we thought we should put in, which is verifying that the tool requested by the LLM is one of the available tools. And that's because a large language model could always hallucinate. There's no guarantee that it will actually call one of the tools that are available. It could make up a completely different tool. And yes, you want to make sure that the tool that the LLM requested is there. So that's what we're doing right here is we're just checking that the tool requested is one of the allowed tools. And you'll see here that in both of these cells, there are some placeholders, your answer here, number 1, and your answer here, number 2. And this is because as you actually run this code, you can type in the correct values and test your code. Okay, now we know what tool the LLM wants to call, and we know that it's allowed, so we'll go ahead and actually call it and print its response. So the agent, once again, is in charge of calling the tool. And the tool was called, and we got a response, which is added 5 apples. It's a natural language response, so this is something that the LLM understands. Great. So we just went through all the code that you need to do a tool call. Now, this was broken up in a few cells just because I wanted to walk through it with you and really explain what was going on. However, for convenience, we are actually going to take all of the code above and put it all in one method. It does exactly everything we just discussed. It takes in a tool call object, extracts the parameters, verifies that it's a valid tool, runs the tool, and it returns the tool's response. And we'll use this method again and again throughout the notebook to call tools. Okay, now that we've discussed how to call a tool, we'll talk about the interaction between the agent and the LLM. Before we move on to that, are there any questions about tool calling? No questions. Okay. Okay, then let's move on to the actual agentic loop, which is, to be honest, the most exciting part. Once a tool call is complete, the agent will report its outcome to the LLM, as we discussed earlier. So the agent captures the outcome and then reports the outcome back to the LLM. And the LLM might respond with more instructions. Then the agent will effectively operate in a while-through loop, calling tools whenever the LLM requests them, and it will only stop when the LLM is satisfied. Now, in a production level scenario, you probably don't want a plain while-through loop. You would want to put in some guardrails so that the LLM cannot just call tools indefinitely. That would be not very useful and also very expensive. However, for the sake of this simple demo, we are just going to put everything in a while-through loop. And as before, I'll go step by step through this interaction between the agent and the LLM. And at the end, when we've run all the code step by step, I'll take it all and combine it into one single method that we can reuse. Okay, so all interactions between the agent and the LLM should be recorded in a message log. And this is because we are calling the LLM in a completely stateless way in this demo. It's possible to have stateful requests, but that is just more overhead, and so we're not going to be doing that for this demo. Every time we send a new request, we'll remind the LLM of what has happened previously so that it knows how the agentic flow has evolved thus far. So at the very beginning, the log will just look like this. We'll put in the system prompt and the user prompt. And I've put in a utility function here to print the log. It's just a convenience for us to see how the agentic flow evolves as time goes on. And here again, you see that these are just initial instructions for the LLM with the system prompt and the user prompt. Okay, now that we have this log, we're going to ask the LLM what to do next. This is the very beginning of our workflow. We just have the user prompt, and we're going to send along the system prompt and the user prompt to our LLM. We are going to send the list of tools. This is that same object we saw earlier where we are describing every tool, what the tool does, how to call the tool. And will send that over to the LLM using the OpenAI API. Again, if you're using a different provider, the API might be a bit different, but the concepts are still the same. So let's send this message over to the LLM. And let's display the LLM's response with its decision of what we're going to do next. Cool. So the LLM learned that we want to make fruit salad. It learned that we have some tools, and it responded with a series of tool call objects. These are the same objects that we saw earlier, where the LLM provides the name of the tool that we want to use, so add to cart in this case, and then the arguments, add 3 apples. And you can see that the LLM went ahead and provided not just one tool call, but multiple tool calls, because it wants us to add a whole series of different fruits, apples, bananas, oranges, grapes, and so on. So we'll go ahead and update the message log with all these requests that we've just received from the LLM. You see here that this is all the LLM wants us to do. That's a fairly demanding LLM. And then the agent will go ahead and execute, in this case, the very first tool call. This is because the agent is the middleman. It takes in instructions from the LLM and actually executes the tools. And here we have indeed added 3 apples. So this is the response to the very first tool call. And this step where the agent executes the tools is where we can put in a lot of security measures to make sure that we don't do anything bad, or that the LLM hasn't requested anything bad. And here again, you see there is a blank your answer here where you can fill in the code. Now, the agent got this response. We've added 3 apples, and it will append the outcome of the tool call once again to the message log, saying we have added 3 apples. This is it. I know it was quite a bit of boilerplate code, but this is literally all we need to set up an agentic workflow. And here I'll go ahead and combine all the steps that we just talked through into a single loop. It's called submit request. This is where we'll submit our requests to the agent. We'll pass in the user prompt, and then it will just do everything on its own. So I'm going to go ahead and compile this. It's going to initialize the message log, and then we'll enter a while true loop, as discussed earlier. The agent will ask the LLM what to do next. This is the same call that we saw earlier in this notebook. It will update the log with the LLM's response. It will execute any tool calls until the LLM responds with no more tool calls. Then we are done. And for each tool call, the agent will append the outcome to the log. Okay, so we are ready now to test this agent. Before we do that, are there any questions about this code? I see that there's been some activity in the chat. Are there any unanswered questions from the chat? Oh, I see one that says, yeah. Oh, go ahead, Georgia.
No, just somebody is asking whether or not we should tell the LLM first what are the functions. I believe you mean, do you mean in the prompt? If in the prompt, we don't really have to mention it in the prompt. Here we do it just to make it a little bit clearer. We definitely have to let the LLM know that there are functions. The way it happens in this API is through the tools argument. Feel free to speak up if you want us to expand more on that, yeah.
Yeah, if you don't tell the LLM which tools it can use, it will never call any tools because it doesn't know that there are tools available. And the core of agentic AI is this ability of the LLM to call tools. So I think it is necessary for an agentic workflow, because with no tool definition, there would be no tool calling, hence no agentic AI. And then I see that someone pasted in the chat, yes, this, again, a snippet of this code that I'm showing right here with the tools part highlighted. And this is where we are passing in the tools to the LLM. So here, when we pass in the messages, we are letting the LLM know what is the system prompt, what is the user prompt, And here, instead, we're letting the LLM know what tools are available. Cool. So after scrolling through all of this code, let's actually go ahead and test the agent, which is the fun part. So I'm going to start with an empty cart, again, an empty Python dictionary. And I'm going to ask the agent to add some items. In this case, I no longer want fruit salad, so I'm going to ask the agent, please add all the ingredients for lasagna into the cart. And I'm going to run this. And you'll see that indeed the agent decided, or the LLM decided that all these ingredients should be used for lasagna, and it, through tool calling, it populated the cart. So each of these are individual tool calls that were issued by the LLM, then the agent executed them, and this is the result. All with the code that we've written so far in this notebook. So it really wasn't that much code. You might notice that there is also like there is some implicit knowledge of what are the ingredients for lasagna in here. We didn't tell the LLM what the ingredients are supposed to be. It figured it out on its own because it already has information of what this dish is from its own internal training. We could always enhance this demo with additional tools that the LLM can use to look up recipes or to search the internet. But in this case, it just used its own knowledge to figure out what ingredients should be there. Now, I've noticed that there is some ground beef here in this list of ingredients, but I actually wanted vegetarian lasagna. So I'll go ahead and tell the LLM to remove some items. Please remove all meat from the cart. But I'm not going to say which meat. I'm not going to provide any further detail. I'll just go ahead and run this cell. And you can see that the LLM called a tool, which is what's in the cart, to actually read the cart, understand what's in there. Then it identified the ground beef as the meat item, and it called a tool to remove it from the cart. So it made a decision based on what it was observing about the universe it knows of. And indeed, now we have no more beef in the cart. Cool. Okay. I'll give you, I would say, 5 to 10 minutes to actually click through this notebook on your own. Remember that you will have to click every single cell. You will have to run every single code cell because they all depend on each other. They build on each other. And at the end, you can go ahead and change the prompts that we are sending over to our agent. You can give different instructions, experiment with different requests, and see what you get. And if you get anything interesting, please feel free to share it in the chat. In the interest of time, let's go through the notebook and fill in the blanks, and then we'll move on to the next section. So the very first field for your answer here is your answer here 1, and this would be, it would be tool call.function.name. It's because we are extracting the tool name from this tool call object, and it's tool call.function.name. So we're just extracting this string here, add to cart, from the tool call object, which is passed in. Next, we have check if the tool is available. So once again, we want the name of the tool here, and we want to check if it is within the allowed tool names. So beforehand, we had already extracted it in the previous line. It was the tool name. We already have that variable defined. So we're just going to put it once again in here as tool name. And we can check that indeed these cells are still running fine. And the third fill in the blank was somewhere here at the bottom. This is your answer here, number 3. We're executing the tool. So what we want to get is the tool calls. We have the tool calls objects from the response that we just received. We received the response over here. So response was set in here. Response had a tool calls field, and we want to get the first one of the tool calls. So it would be this object over here. This is the first tool call that we're trying to capture. And so I'm just going to go ahead and paste it here. And Python is 0 indexed, unlike ObjectScript, which is 1 indexed. So we are taking the 0th item. Cool. Okay. I would say then, Georgia, feel free to take over the screen to move on to the next section.
Thank you, Marta. If people are ready, I'm ready to go.
These notebooks will stay up after the workshop, so you can feel free to return to them at any time.
Great. Before you finish, Marta, I want to point out that at the end of this notebook is the link to the next notebook.
Right.
For the next notebook to work, and so you all see all the results, it's better if you use Chrome. If you don't, also what the results are supposed to be at the very end. But if you can use Chrome, please do. You might have to copy the link, and I can wait for you.
Mm-hmm.
So with that,
I'll paste the link in the chat.
Thank you. With that, I'll go ahead and share my screen. Hope you can all see it. Okay. And we're going to take a small break from the code, and we're going to talk about MCP. So for those who don't know, MCP stands for Model Context Protocol, because it is a protocol about the context that goes in the model that is basically our LLM. And what I'm going to try and discuss is I want to explain to you some use cases I ran into while I was trying Marta's ideas. And we're going to see how we can fix the issues I had. And I just want to remind you that Marta briefly showed us that we can use functions and give them to LLMs to decide what to do next. And the way we do it is by having an agent that controls what is going to actually run and lets the LLM know what are the results of those functions. So with that, I was trying to think how I can enhance my shopping cart agent. And I really wanted to say that, maybe it can look what I have in my pantry or in my fridge, and maybe it can check whether I have time in my calendar to receive deliveries. And maybe it can do like ask for the delivery as well, or check the prices so that I stay in budget. And as Marta was explaining, we can add functions, more functionality maybe for my LLM to eventually pick to do another action. And to do that, I would need to create another function for my pantry, another function for my Google Calendar maybe, and for my price checker. And for all of those, I will need to go and figure out what is the API I need to use, for example, to see my Google Calendar. And this is not a function that I made, this is a function that Google made. So I would have to learn different APIs, and these are called integrations with other functionalities that somebody else might have. And then, well, I wanted maybe to also have a smart home app And this was very different than the first one. This was written in Java. And now I would have to redo the same thing for some of the things that I tried before. I would have to make some functions for my pantry and my calendar and for extra things that I don't show here. But basically, I would have to learn the same API in a different language for my new application and do very, very similar steps. This is called the N times M integration problem because I have two apps and I have three different tools that I might want to integrate. And I had to write N2 times M, three different functions. And what's the problem with that? Well, I can do it. It's like I can definitely go ahead and do it. But the thing is that I cannot necessarily reuse functionality that I wrote. Like some tool, I might not be able to reuse it in my other apps. And I still have to maintain all of those. So what else can I do? Well, the idea behind the MCP protocol was that maybe instead of having to write tools like in the language you're writing them, maybe what you can do is that you can imagine that there is a server that has the tools, and you just go and ask the server, hey, what tools do you have? Can I use them? And then the server says, okay, I have these tools that you can use. And it runs like you can imagine it running as a service, serving you results. So that's the main idea behind it. And for example, here you can see that I have an MCP server, for instance, for my Google Calendar, and both of my apps, the only thing that they have to do is connect to the server and get this functionality. And this yellow line over here is the integration that I did with this API for the Google Calendar. And this can be written in any language that I want. And the idea is that if I make it so that I have to ask a server, then I depend on the network and I'm language agnostic instead of having to write tools for each app depending on the app's needs. And you can see here, I did that for my Google Calendar, I did that for my Pantry DB, and I did that for my price checker. And the only thing that I have to do is write three integrations, and everything else is just a connection to these servers. But what does that even mean to have a server and a client communicating through the network? What does it really mean? Well, it is, you can imagine it as the USB-C for AI. So the USB-C is basically a hardware interface. And they, like all the vendors that sell hardware, have agreed that they can support that. And so we're able to connect different devices through that interface. In a similar way, the MCP is like a protocol that defines the communication between two parties so that they can exchange tools and the results of tools, and you can do the things that you want to do with your LLM by using the tools as a service. And so what we saw Marta do, it was that she needed to define the tools and she needed to describe them. And then she would pass this description to the model, and then the model was able to decide to use one of them. And every time it would need to use something, it would go and ask to the agent to run it, and the agent would run it, and it would get the results, and it would pass them back to the LLM. Now, the same thing applies here, only that now, because we use these tools as a service, the agent has to go and find the service server, the MCP server, for the descriptions, pass the descriptions to the LLM, and whenever the LLM wants to run something, it goes back to the agent and it says, okay, I want to run that. And so the agent at this time, it has to go back to the MCP server and request to run the function. The server is going to run the function in the background, and then it's going to send back the results. And all this happens through the network. Now, for this to be able to happen, we have to decide on a common language that each part is going to have in order to be able to communicate. So I have to say that whenever I want to run a tool, I'm going to ask you to run the tool in a very specific way. And what does it help? What does this system help? Well, as I explained, it allows you to be language agnostic, but it has a couple of more benefits. One of them is that if, for instance, I want to use the Google Calendar API, and this is an API that Google has described, has defined, then I give the power to Google to decide what tools I'm going to access. So this can be more standardized based on the vendor. And in the same way, I give the vendor the control over what I will be getting access to by allowing them to define the functions for me. So of course, I can go ahead and make an MCP server myself. But because of the separation of concerns, I'm also able to say that, okay, Google can provide me this MCP server. So Google, let's say, would write the tools for me. I wouldn't do it. And apart from that, I also get another benefit, which is now I'm able to focus on my actual application instead of focusing on making integrations for each thing that I want to use. And you can think of it as plug and play components for your applications. And with that, I'm gonna go and explain to you a little bit what happens under the hood. So in whatever Marta was describing as the agentic loop, we have functions and the agent living on the same machine. In fact, they're part of the same application. So whenever the agent wants to call a tool, they go ahead and call the tool, get the results, and give them to the LLM. Now, in the MCP world, these functions are going to live in a separate machine. Oh, let's call it in a separate entity. This can be a separate process in your own machine, but it can be also a completely different machine. And the agent is going to have to go and say, okay, what functions or tools do you have available? And the server who is serving these functions is going to be able to say, okay, I have these functions available. In the same way, when the agent wants to call one of the tools, it has to go and say, can you run this tool for me? And then the server is going to run the stuff and it's going to get the results back to the agent, who then communicates them to the LLM. And as I said, this needs to be standardized. Here is an example of what these functions look like in Python. Whenever I want to learn what tools are available, I have to call a function called list_tools. And when I want to call a tool, I have to call it using the function called call_tool. This is based on the Python API. Different languages might have a slightly different syntax, but it's pretty similar. But of course, because we're talking about a network specification, what the network specification describes is how are the data going to be communicated, which is not exactly these two calls that I'm showing you. In fact, the two parties communicate with JSON RPC, which has the exact format that I'm going to show you here. When you want to get tools, you have to send a message to the server that is formatted like this. You have to say that I want to use the method tools/list. And this is just the ID that shows which message it is. In this case, it's the first message. And then the server is going to respond back with another JSON formatted message, and it's going to have a section which is going to be called results. And in the results, there's going to be a tool section which is formatted the same way that Marta was showing to us before. And this is all part of the specification. This is what happens under the hood when you call this list tools function. It's not going to be necessarily visible to you, but this is what it looks like. And then when you want to call a function, similarly, you call another, you have to send another message that it's going to have a different method type over here. And it's going to contain the parameters that you want to pass to the server so that it can actually make the call. And once the call is completed, the server is going to return back the results. And the results can be first of all, it needs to communicate two things. The one is the actual results from the function, and the second thing is whether or not there was an error. And the way the communication happens is mostly through text, because the LLMs understand text, but there is a way to return, I believe, and to return and send, for instance, images. I believe there are a couple of types that you can return, but this is not necessarily going to be visible to you when you make these functions. This is automatically handled by the APIs that the MCP protocol people made. And with that, I want to say a couple of things. So in a way, it is like the AI, the agent, discovers the tools at runtime. It knows what service it wants to use, but it doesn't necessarily know the tools. It's going to get them on demand. And it's going to get them using the messages that I showed to you before in a format that it's JSON RPC, which is a format, a network communication format. And again, in a way, we give control to the vendor to decide what it's going to send back to us. And just to give you a little bit of a history, this was made by Anthropic 2 years now ago, almost 2 years ago, and it was adopted very, very fast. And it was adopted very fast because it allowed you to basically share tools. It's not the only development that has happened, but it was a very significant one at the time because it allowed people to use LLMs more in their systems. And so because of that reason, many other vendors adopted it. Like Anthropic and OpenAI and Google, they are competitors, but they still they found interest in that because it would allow users to actually use their systems more. And because we're going to talk about frameworks, I want to point out here that this is a network protocol, and it allows you to be language agnostic. It gives you some freedom. The frameworks that we're going to discuss a little bit later, their purpose is not the same. The purpose is to hide boilerplate, but they're still tied into a specific language or a specific interface they define. So you still have to learn something specific to the framework, and you're still locked in both to the framework and the language you're using. But what they give you is flexibility, is the ability to swap between different vendors when you want to decide, let's say, what type of LLM you want to use. But we're going to see that a little bit later. And just for some resources, I highly suggest that you read the actual specification if you're interested. We're going to see some code right after, but I always think that it's not that big and it has some great graphs. So if you wonder how things are happening under the hood, you can definitely go and read it. It's not that long, and it's going to give you some understanding of how things work. But before we move on, I also want to point out that I'm going to show you how to set up an MCP server. But sometimes it sounds like a superpower, really. But the truth is that it adds some overhead, and you will have to implement both a client and a server, and they're going to have to communicate over the network instead of being on the same system. So sometimes you might still choose to go with writing the functions yourself. And before I move on to the code, I want to ask if there are any questions. So I hope you already opened the notebook, the next notebook, which is called Agentic Frameworks and MCP.
I just sent it in the chat as well.
Okay, thank you. Thank you, Marta. And I want to remind you what we're going to be doing here. We're going to try and take Marta's example and create an MCP server and an MCP client and separate the functionality from the agent. So I'm going to go ahead. I've already run the first cell, which does the setup for the answer keys that you're going to have through the notebook. And I'm going to go ahead and run the initial system prompt is the same. The shopping cart, I set it to empty. And I'm going to define here the functions. The code, you can click the show code, but the code is the exact same code that you had in the previous notebook. And we're going to try and define these two functions and the server and the client. And just as a reminder, now because we separated the functions in a different entity, we'll put them in the MCP server, there's always going to be needed to have like the initial setup over here, which is the moment that the agent connects to the MCP server to receive as a service the tools. So that's why I have this gray piece here. But then the flow is very similar to what Marta was showing. The LLM gets the list of tools at the very beginning. And so it's able to decide whether or not it wants to run something. And then it asks the agent to call the tool, but now the agent has to go through the MCP server to run the stuff. The API I'm going to be using here is the Python SDK for MCP, which is the first SDK that was defined by the same people who wrote the protocol. Here I'll first define the server. This is just a class called server that you have to define whenever you use this, this API. And I'm going to go ahead and define the server tools. The way I'm doing it is because I'm using this specific API, this API requires you to pass the tools using this tool structure. The tool structure is going to convert whatever I'm going to pass into a format that is very, very similar to what Marta, actually probably the same with what Marta was showing to you before. I just have to define it as a tool before I pass it to the server to send it to the client. So I'm doing that over here. And just for reference, you see, again, I have the name, the description of the tool, and the input schema describes the arguments that it takes and whether or not some of them are required. And I have here for you, one for you to try. The actual answers can be inferred by the previous notebook. So if you have the definitions of the functions from the previous notebook, you should be able to go and fill in the blanks. That said, I told you that we have to define the list tools. The list tools just has to return the tools that we just made. And whenever the client is going to be calling to get the list tools, the server is going to be sending back this list of tools. And we're going to have to define the call tool function. Now, these steps to define it are the exact same steps that Marta was showing before. First, we have to check what are the tools that we have available so that we can check whether or not the function that was requested to be called is within the tools. And then once we have it, we just go ahead and make the call. These globals here is just picking up on this definition of the tools that we made previously. So let me go ahead and run that. And so now I have defined the two main functions that they're going to do the work for me. The next thing that I want to do is actually define describe the server. Now, to describe the server, whenever you have to make a server, you have to write some network code and explain things like how you're going to allow connections to come to you. I'm going to use the FAST API. And I'm going to use also the SSC server transport. There are 3, I believe, types of transports and 2 main ones. The one that I'm using here is used when you want to have your server running on a separate machine, or if you want to actually go through the network. There is a separate type of transport you can use when you want your server to run locally, and it's called STDIO, which means that it uses file descriptors to talk with your server so that it's actually faster. These details you can go ahead and read more about in the MCP specification itself. They're not very important because all we're trying to see is like how we separated the concerns and that the system actually works. And all I do here is just define what I'm going to be using to receive messages. And this just says that I'm going to be listening to this specific route for incoming messages. And this piece of code over here is just also for my convenience. And it's just, all it does is to handle the incoming messages that come to me. This is just almost boilerplate. We're gonna see later with the framework talk that this is not like, this is gonna be hidden from you in some cases. To learn more about it, again, you can read the specification and the Python SDK. So I'll do that. I define some functions here that they're just for my convenience to run the server in the notebook. And here I'm gonna go ahead and start the server in this port and define the URL that the client is gonna need to access the server. You can see this is running on the local host in this port, which means it really runs in a different process in this environment the Colab is running. And now let's see what we have to do when we want to connect to the server. As I created the server, now I have to go and do these initial steps that I showed here. Basically, I'm going to describe in the agent side some functionality so that this first piece happens every time that I want to communicate with the server, and so that the agent actually uses properly the Python SDK to call the functions that I made before. Let's go over here and do that. I'm going to define this list MCP tools. This is just going to do the initialization step. And once I have the connection, I can go ahead and call the list tools function and get the results that I can pass them to the LLM. And as we can see here, I already called that and I got the 3 functions that we made back, which means I'm already able to connect to the server. And just to point out here, this is actually where the connection happens. This is where I pass the server URL and actually connect. And then this is just for the session to in this connection. And the next function that I'm going to define, it's just going to go ahead and do the same initialization step, and then it's going to try and call a tool. So I define it here, and we're going to try to call the function on the server and see what's going to happen. Now remember that the server has an empty cart, so I'm going to try and add some cherries. Then I'm going to challenge it to try and remove some bananas and see what's going to happen. And at the end, I'm going to try and see what's in the card so that I verify that I indeed only have cherries. It's okay. I got back, it tells me that it added 1, I guess, pack of cherries. And that's all that I'm going to be getting back. The responses are basically like text. So I'm not able to verify besides like going back and forth. Here I'm going to try to remove the bananas, and okay, it tells me there are no bananas in the cart. And at the end, I'm trying to see what's in the cart, and it tells me that, okay, you have cherries. So I feel confident that I'm talking to a server that had an empty cart and everything is working well. So before I move on, are there any questions? And now I'm going to talk a little bit about the LangChain ecosystem and just give you a small, like, I want to have a discussion with you about frameworks. I'm not going to go in great detail about the LangChain ecosystem to the extent that I'm going to talk about functions and everything. They have a lot of great tutorials that you can go ahead. But what I want us to discuss is that you can use also frameworks to hide a lot of the boilerplate that we saw before. We showed you, Marta and I showed you how you can actually do stuff from scratch. But one thing that we didn't discuss is that we chose to use here the OpenAI API. If you want to use Anthropic or you want to use something else, you would probably have to change all of your code. So with that in mind, you can imagine that if you work on a project, you might need like to swap your code. It's not very convenient. You might prefer to be able to test the different vendors. So that's the idea behind the frameworks. So because everybody was going and developing their own APIs, the LangChain started as bringing the idea of putting a common interface that everybody is gonna be able, well, how can I say it? That it's a common interface that I can use to communicate with any type of vendor. When it comes to LLMs, when it comes to pretty much anything that you could use in an application that uses LLMs. And this can be vector stores, it can be databases, it can be specifically LLM completions, etc. So this is how they created the core framework, which is the main LangChain library. And if you go read about it, it basically has a way for you to call the LLM and say that, okay, I'm going to define a class that I'm going to use, which is going to be the OpenAI. But everything else is like, I have to define at the beginning what type of vendor I'm going to use. But besides that, the code is going to remain the same, even if I use Anthropic or Google's API for Gemini. And you can see here, this was created, I want to say, when like 2 or 3 years ago, along with everything else that was evolving in AI. And through the years, it grew. So now, apart from this library, there exists something called LangFlows, which helps you design and prototype, and it's a low-code experience that basically you can use UI to describe your system. The LangChain, we discussed that. The LangGraph, it helps you define in code. It brings the idea in of creating the orchestration of the system. So basically it has extra functionality that is going to help you do the orchestration in code. And Langsmith is just helping you. It's another library that is going to help you debug and evaluate. And with that, I'm going to show you what do I mean by hiding the boilerplate. What I'm going to do, I'm installing the libraries first over here. And then I'm going to show you how I'm going to connect to the same MCP server and do the agentic loop with very, very little amount of code. So here, I say that I'm going to connect to an MCP server and get functions from there. I use the same URL that I defined before. Here, I'm just getting the port from a previous cell. And I'm just saying that I want to connect to this MCP server and get functions. So I do this over here. This is just a class that exists that I can use for that purpose. And here, I'm going to go ahead and get the tools, list all the functions that this MCP server has. And I'm going to store them in this variable. As we can see, I grabbed everything, and I can see here both the name of the function and the short description of the function. So now I'm able to take those and give them to my LLM as functions. Since we had this question before, you can imagine that because this is a list, I can add more functions here before I pass it to my LLM, that they could be local functions. And here, I'm going to go ahead and create my agent, give the tools, and say which LLM I want to use. Here, I'm going to use the OpenAI's GPT-4o. If I wanted to use a different vendor, this is the piece that I would change, but everything else would remain the same. And with that, I'm gonna create a function over here that is gonna run the agentic loop so that it can go back and forth with my LLM and ask it whether or not it wants to run some functions and do the full loop that we saw before with Marta. Again, I have to provide my messages, basically give the prompt to the agent, to the LLM, and give the user prompt as well, and also tell it what functions we have, because we built the agent over here. The agent already knows what tools it's going to pass to the LLM. And this piece of code is basically the only thing that we have to actually write to make the loop happen. Only thing we have to do is like basically invoke the loop, and here are the initial messages. This following piece of code is just for our own convenience to see what's happening when we run and we get results back. So I'm gonna run it. Like, you don't need to really read it. It's just for us to visualize things. And I'm gonna go ahead and try and do what Marta did before. Imagine, I believe we only have cherries. I don't think we removed the cherries from the cart. We're gonna see at the end whether they're there. And now it should go ahead and do like similar steps with what we saw before. And we see here, okay, it got all the lasagna ingredients and it added them to the cart, and it verifies here it did. Now, I am Greek, actually, for those who don't know. I'm not Italian, so I want to tell it, I really don't want lasagna, just did that for testing. Please remove everything from lasagna and add ingredients for moussaka. So let's try that. Okay, at the beginning, it checked what is already in the cart. You can see that here it did have the cherries that we added before. And now it has to identify what ingredients it wants to remove. And it says, okay, remove basil, remove lasagna noodles. Because there's some ingredients that it might have in here that I might reuse for moussaka. You can see that it did not remove the garlic. Great. And it started adding more things. So we see it works exactly as we saw before. The only thing that has changed is that we are using a framework and we are using an MCP server. And just to try, I also want to add the ingredients for hot dog. Now, I didn't ask it to remove anything, so it should just be adding stuff. Okay, just check first what's in the cart. Ah, interesting. Did I say to remove? Yeah, actually I said take out. Sorry for that. I asked it to remove the ingredients. So it first removed everything and it then added one hot dog and one mustard. This is very interesting. I didn't expect that. I would expect bread separately from the sausage, but that's okay. This is a decision made by the agent. So before we move on, I want to address one thing. We saw that the amount of code, it was reduced by a lot. I just had to write that and I had the loop. I just had to say here that I want to use the OpenAI, and that's all. I didn't have to do any of the other things we saw before regarding extract results or do anything fancier than just write these two pieces of code and connect to the server. That said, the frameworks remove a lot of the boilerplate code from you. But what did I actually have to do? I still had to go and learn what calls I have to make for this to happen. So I have to go and learn a framework. And once I learn it, then I'm locked in the framework. Because it has a lot of abstractions to help me, unless I know them well, I'm not going to be able to operate to the same, like I won't be able to do the same decisions that I would make if I was to do everything from scratch, because it hides a lot of things from me. So it's always good to be able to assess when you're going to use it and why. And still, it's a good idea to know what's happening behind the scenes. So if you need to debug something, or if you're trying to understand how things are happening, and you might want to decide that, you know, maybe I can optimize X, Y, or Z, then you know. But it's definitely very, very helpful, and it's going to reduce the amount of code that you're going to write. I'll take any questions before we move on.
Okay, I will take over the screen, and I will share a video recorded by Don where he goes over the next section of this notebook, which is creating a coding assistant.
Okay. All right. So what we're going to do now is we're going to take kind of everything that Marta and Georgia walked you through, and then we're going to take it from, you know, kind of a simple example of the shopping cart. And we wanted to do a simple example, so you got the main root concepts, and now do something quite complicated, which is to implement a coding assistant. And basically, we're just going to implement it. It's not going to take that long, actually, and you can implement essentially Claude code, you know, without that many more lines of code. Okay, so let me just describe the use case we're going to do, and let me describe it this way. So I'm a runner. And part of running, you have these training plans where you have to run like 5 miles. And in that 5 miles, you have to run 3 1-mile intervals. And the 1-mile intervals need to be done at like an 8-minute a mile pace. And then when you're resting, or the rest of the 2 miles, I guess, you could do it at a 10-minute per mile pace. Okay, so I was doing one of these training plans, and I was flying to Europe, and I was in the fitness center, and the treadmill was all in kilometers. So it was in kilometers, and then all the paces were kilometers per hour, maybe, or something. And I was trying to run and trying to do all this math in my head, and it was very, you know, very confusing. And so on the way back, I wrote this little bitty application, which I'll show you now, called the metric treadmill. And what it does is you type in your slow pace, basically. You want to run, I'll do my 10-minute pace, let's say. 10-minute miles, 5 miles, but within that, I want to do 3 1-mile intervals at 8-minute miles. And so this would kind of convert it all for me. So this runs on my phone. I could stick it right on the treadmill, and it would tell me when to change the speed on the treadmill and what to change it to. So basically, so that was the use case. So I wrote this 9 years ago, and it uses all old code that I feel is going to die at some point. So if you're familiar with these frameworks, it uses jQuery, which is an old-fashioned thing. It uses jQuery mobile because this runs on a mobile phone, and that was some library from way back when that was helpful to that. If you look at the application itself, this is jQuery. Everything with $ is like jQuery finding parts of the DOM. And you could see all the JavaScript variables are initialized with var instead of consts and lets, which we do these days. So I just felt like this thing was going to die at some point, and so it needs to be modernized. So that's our use case. We're going to modernize this little application in this class here. Okay, so I'm going to set up the system prompt, not too fancy. You're a helpful assistant. Actually, let me take a step back. So we're going to implement this whole thing by only adding one tool. So we're going to leverage everything you've seen so far, that MCP server, the LangChain framework, though we could have done it with direct orchestration as well, but I just wanted a continuity. And we're just going to add one tool. And that one tool is Bash. And for folks who are Windows people, this is like the command prompt as well. So in Bash, you can look at files, you can read files, you can edit files, you can run code. You can basically do anything that's needed to do coding tasks in Bash and more. So that's all we're going to do. We're going to add one tool, and we're going to have better prompts that are dealing with coding, not shopping carts, and that'll do the trick. At least we'll see. So here's the system prompt, your helpful assistant. Always provide reasoning before calling any tool, so we can see what it's thinking, basically. So there's a thought section that I'm asking the LLM to produce before requesting a tool. Okay, and I'll show you how that works. The user prompt, should I ran this? The user prompt is a little bit complicated in that there's a template for the user prompt as well, which has more particular instructions around how to think about modernizing apps or bug fixing or enhancing or building a brand new application. So you can read this for fun at your leisure, but it's basically, let me find modernization. For modernization, inventory outdated dependencies, propose a modernization plan, apply updates incrementally, ensure backwards compatibility, or provide migration notes as needed, blah, blah, blah. So it's just kind of steps to doing it. Never run long-lived servers. If you must start a server, do it in a particular way. Yeah, here's how to start a web server if you want to do that. Here's how to do timeout. Here's how to do assertions, all kinds of stuff. So so it's kind of a general purpose coding guidance prompt, which is part of the user prompt in my little case. Okay, so now here's the one tool we're adding. We're adding bash. The argument to bash is a command. So a bash command is like ls will list the files in a directory and the subdirectories. So you pass in that command. This is the way something is run as a sub process in Python. So it'll take that command right there as the first argument and run it, basically. Runs it in the directory where the code is. And there are little bits and bytes here. One of these, the model we're using keeps sending me non-ASCII characters, so I check that and flag an error, so the LLM will try again. It was having trouble with binary data sometimes, some error handling, so a few things like that. And this is the description of the bash tool. When you provide tools, you provide a description. The shopping cart tools, there was a one-line description, but this is a little bit more, 20 lines or so. How to create a new file, how to edit a file, how to view file content, and then any other command you want, go ahead and run. Okay, so that was the description of the bash tool. And now what I'm doing is that was the function to execute the tool and the description. And now what I'm doing is I'm enveloping that description into the proper form that MCP wants. So you can see I'm using the bash description here. I'm saying there's a one argument called command, and it's a string, and this is a description of the argument. And I'm appending it to server tools, that variable that Georgia showed earlier. Okay, so that's what that does. So now I have a tool. Now we want to stop and start the server. The server reads that server tools variable. And so now the tool is added, and you can see that it's added. So I asked the server here via the client, what tools do you have? And it listed these 4 tools. So now you can see the bash tool is there. I didn't bother taking out the other tools because the coding assistant, I would hope, would not use them, but they're available. Okay, so here's my main prompt. I have a web app, wrote many years ago, converts my running plans into a metric system. I think it's going to stop working someday. Can you help, eliminate these deprecated libraries and such? Here I'm putting the user prompt inside. I'm enhancing it with that template, so I'm tucking it in the template, basically. Here I am grabbing the code from GitHub, my 2017 version of this app. So if you look in Colab, you can look at the files here. You can see here is the directory with all my code. So my index.html, app.js. I forget what this wasn't in 2017, that part. But that's the app there. And here I am asking for the list of tools in order to tell the LangGraph agent about the list of tools. This tool is from MCP. And we're also using an updated model here, GPT 5.2. If you use 5.0 and before, it just doesn't do a good job actually with this task. So so you have to use the latest and greatest from OpenAI. Claude does better actually, but to keep the API keys simple, we decided to use OpenAI if we could. Okay, here's the initial message with the system prompt and the user prompt. And here's basically the function that, that runs the loop. So some of it is just a repeat here for various reasons. And then here's the loop actually. This is called a Python generator, and it emits this event every iteration of the loop. So it kind of looks like a for loop, but it's yielding it. And I forget what it's called in other languages, but it's kind of iteratively spitting out these events, and we just print out what's going on in that event, in that iteration. Okay, so that's the main loop. We're not running it yet. We're just defining it. This is just a helper function to print the event. So nothing intellectually interesting here. It's just just handling pretty printing of an event. So now before I kick off the whole thing, let's just run the very first iteration so you can take a look at what it looks like. So this sends that initial message of what I want to do, and then gets the very first event. The very first event is saying, hey, I need to inspect the repository to understand what kind of web app this is, identify old libraries, then plan a safe modernization. And this is how I'll start. And then there should be a tool call here. Here it is. It's using the bash tool. Of course, that's the only tool other than the shopping cart that it has. And here's the arguments. There's a command argument, and I want you to run ls-la, so list the files in the directory, and then find in this directory, looking 3 subdirectories deep, maybe the word type, the word print. Actually, I don't know the find command that well. Somebody in the audience will know that. But okay, so list the directories, look around for what I'm looking for. So that's just pretty printing that. So I list the thought, and then I list the bash tool request. So now with this cell, I'm just going to kick off the whole process, and I'll explain it as it's going through. Now this is a live demo, so I don't know if it's going to work or how it's going to do it that well. I need to inspect the repository. This model, for some reason, often asks for non-ASCII characters. That's why I had that check there. So my tool call just says error, commands non-ASCII characters, and it says, oh, I guess I'll adjust. And then it tries again, and this time it did it right. So this is listing the elements of this directory, which it does look like an older jQuery mobile-based static app. So it saw that from probably the directory, that subdirectory name. Show me the first 220 lines of the index.html file. And this tool result is outputting that file. I cut it at those 3 dots, but you get the idea. Show me app.js, the first 260 lines. So I go ahead and do that. Okay, so it has a goal. Let's remove jQuery mobile. Let's replace with vanilla JS. Let's do responsive CSS. Blah, blah, blah. So you can see what it's trying to do. Yeah, another error. These LLMs are not perfect. Okay, so now styles direct. So it had trouble. Oh, the styles directory probably contains some images, but it found main.css and asked for the first probably 200 lines of that. Oh, it's probably piping that stuff over. Okay. Anyway, so it's main.css, lots of unused styles. Okay. Now this is starting to write a new style, a new main.css. This cat after or before end of file is the technique to do it with bash. Now I'll rewrite app.js. It's doing app.js there. I should remove this directory, so it's removing a directory. Let's do a quick static validation. Let's look for jQuery and make sure it's not there. Let's kick off a web server and see if it works. So it's, I think, did. Grabbing the process ID and then curling, the main page, and then killing it. Killing that process ID, I think. Adding a README, ensuring that everything looks good. And then this is part of my instructions. Echo this when you're done, and it did do that. So now it just has comments. Modernize your app, remove jQuery, blah, blah, blah. So, so it did it. So let's see if, so you can look at the code if you wish. So you should see updated code in here. But what I can do in this cell is it starts up a simple web server that hosts that that code. So I'm going to click it here, and you can see it's dark mode. So it redid the app in dark mode, which is interesting. And let's just try it out. So I'm going to do my 10-minute miles for 5 miles, 3 1-mile intervals at 8-minute miles. And down here you see the running plan. Okay, so it worked. And if you look at the code itself, you can see there's no jQuery mobile imports anymore. It's a nice, clean, pure HTML page. App.js, you can see in here, it's using const instead of the vars. You see no $signs, or I guess, oh, does it define $sign? Let's see. Well, it's not using the jQuery $signs at least. It's using a template. Oh, interesting. But anyway, it's not using jQuery to access or edit things on the DOM or figure out when events happen or anything like that. It's using const and those kinds of things. So it's a very modern JS Pro. Oh, it added things. I don't think my original app did things like this. So I think that's kind of cool. So it did the trick. I think we have a working app that's modernized and should last me another 10 years, which is fantastic. So you can also, if you wish, this next cell will download it to your device. If you'd like to do that, you can run it, run a little web server and host it locally if you'd like to do that.
I think what I was thinking of doing is just going with you through the notebook real quick, if you want to follow along. I want to show you that Don was showing how he made his new app. Now, if I want to run the exact same notebook, it's not going to have the same result. Let me share my screen. We'll continue from where we left. Just going to go ahead and click through code. I define the bash tool over here. You can see that this is basically the description that Don was passing to the LLM. He passes to the LLM through the MCP server. It basically just explains what are some things that you can do with bash. So we're gonna add the new tool. We're stopping and starting the server again just because we're adding a new tool and we need to restart for the new tool to be in use. Okay. Perfect. I grabbed it here on my, yes. Okay. Again, this is not going to work for you. The last step is not going to work for you if you're not in Chrome. So if you're trying it live, please use Chrome. Okay. Like if you have any questions, please raise your hand or unmute yourself. I'm just going through the notebook quickly so that we see that I get a different result. And also the amount of iterations might be different for me. Takes a little bit of time to run.
I'm seeing a question in the chat, which is, it ran 51 iterations in my notebook. Would it possibly reach the max token limit? So are we talking here about the max token limit that our API key can support, or are we talking about the context? In terms of the max token limit that the API can support, okay, the clarification is per context. So with aren't again here in this implementation, we're using an agentic framework, and which is the framework that Georgia introduced earlier, which is LangGraph and LangChain, and so they are taking care of the context for you. But if you were doing direct orchestration, and you were keeping track of the context, you would need to manage your own context. So this is a benefit of using frameworks. They often do the context management for you. Georgia, did you have anything else to add?
So yeah, I mean, I agree with you. Generally, yes, you could, like, if you do a lot of things, you might end up, like in our scenario, the amount of steps, it's not that long. And as Marta said, there is some handling going on behind the scenes that we don't see. But yeah, in theory, if you have if you use the same code and try to do something very complex, you might end up running into some token limits depending on what type of key you're using. Yeah, but it's unlikely with just this specific notebook. And to give you an idea also, when we say that the frameworks take care of that, they can basically decide, let's say, to summarize stuff so that they don't keep presenting all the history. They can give parts of the history, which reminds us that there are a lot of things that happen behind the scenes that you have no control of. And you can see that here, I ran mine. It took 47 iterations. And my example looks like that. We can actually try it. Hopefully it is, yeah, it's already producing things. I'm just literally using the, okay. We can see, some of you might get something that looks completely different than that. And you can see here at the end of the notebook, you can download the content that generated. Basically, this folder is gonna be zipped. It's gonna be downloaded. Again, this was generated by an LLM with in a somewhat containerized environment, containerized sandbox. So we did use Bash to generate code, and we trusted the LLM. Now, if you get this code and you try to run it on your system, it's always good to go through the code yourself to verify there is nothing malicious in this code, which is going to bring us to the last part of this conversation here. And I'm going to pass it again back to Marta if you have no questions to share the last video that Don recorded.
Okay, so just a couple final final topics. So, you know, what I did there was just having a bash tool with no like sandboxing or protection on it is not wise. We obviously did it because we're talking about agentic, wanted to teach you how to do this this flow, but obviously there's security issues with that. So maybe we could just have a discussion. You guys could have a discussion about what would make that more secure. Okay, good. I think nobody would do just a plain bash tool like I did. I mean, that makes certain things simple, but you would have more granular tools like to read a file, edit a file, write a file, that sort of thing. You wouldn't let them do any bash commands unless you were really restricted, good sandbox, that kind of thing. You could do website whitelisting, so any commands to reach out to the internet can only hit certain sites. You'd want human in the loop for certain tools, so you might allow the tools to read the directory, but for writing a new file or editing a file, you might want to get user confirmation on that. Validating the output of the tools to make sure what you're writing looks like code and not something else. You know, things like that. So there are many things that you would do if you had more than a half hour, you know, to kind of make this more bulletproof. And just to illustrate illustrate the concept a little bit, some people kind of disbelieve that an LLM would really just, you know, all of a sudden go rogue. You're asking it to modernize a web app and somehow it's going to steal stuff from you or, you know, delete things. Sometimes it does things accidentally, but sometimes, you know, other bad things happen. So take a look at this inbound lab result, let's say. We take inbound lab results all the time in IntelliCare and HealthShare and in our Fire repo and things like that. Do you see anything odd with this lab result? Well, you can see there's a comment field to calculate the normal range, run this shell command, and that shell command will grab your OpenAI key and send it off to a website. And so, so that's not so good. But this can happen, you know, outside data, comments, you know, how much validation do we do on comments? That can get bundled up, can be sent to an LLM with contacts, and the LLM may use that information. So this is kind of an example where, you know, prompt injection, basically. You can get stuff into a prompt that you didn't know was there. So, you know, our product didn't do anything unusual. The LLM didn't do anything unusual, but outside data came in and became part of the equation, and this can happen all the time with systems like ours. Okay, so let me close in a sense by saying I think Agentic gives us additional options to solve problems for our customers. So here's one way to think about it, I guess. This first column is what we've been doing for whatever, decades, where we're hand coding algorithms. We're the brain. We listen to our customers. We kind of build a system that meets their needs. And this is kind of 99% of what we do. Machine learning was a new approach, or is a newish approach. And it's interesting where the data is kind of the brain. So we never figured out in column one here how to write an algorithm that would tell a cat from a dog, believe it or not. We just couldn't do it. But we found this generic learning algorithm, and we fed it 1,000 pictures of cats and 1,000 pictures of dogs, and it sort of figured it out. And so that's the concept of machine learning, which is have done more wonderful things than just cat versus dog. All of radiology, AI, and many other kind of segments of AI are based on this technique where the data really supplies the algorithm by inference and pattern matching and that kind of thing. Agentic workflow, one way to think about it is the LLM is the brain, essentially. So you're configuring the AI system in the way we talked about. It's not rocket science. I mean, we went through the whole story here in this 2 hours and 50 lines of code. It's a concept of assembling the pieces of an AI system and relying on the LLM to do tool calling, rely on the LLM to make the next choice decisions. And this allows a system to kind of roll with the punches of the real world like we do as humans. So you're trying to set up a patient for a next appointment. This doctor's not available. The patient's not available then. You can't get the prior auth. You can't, they'll approve this, but not this. And you kind of work your way through the realities of real life to get a task done. And none of these other approaches are as good as agentic as kind of working your way through the non-deterministic nature of life to get something done. That's why agentic is so exciting. So that's it for me. Back to you, Marta and Georgia. Okay, so just a couple final topics. So what I did there was just having a bash tool with no sandboxing or protection on it is not wise. We obviously did it because we're talking about agentic, wanted to teach you how to do this flow, but obviously there's security issues with that. So maybe we could just have a discussion. You guys could have a discussion about what would make that more secure.
So that is the discussion that we just had.
Okay, good. I think nobody would do just a plain bash tool like I did. I mean, that makes certain things simple, but you would have more granular tools like to read a file, edit a file, write a file, that sort of thing. You wouldn't let them do any bash commands unless you were really restricted, good sandbox, that kind of thing. You could do website whitelisting, so any commands to reach out to the internet can only hit certain sites. You'd want human in the loop for certain tools, so you might allow the tools to read the directory, but for writing a new file or editing a file, you might want to get user confirmation on that. Validating the output of the tools to make sure what you're writing looks like code and not something else. Things like that. So there are many things that you would do if you had more than a half hour, to kind of make this more bulletproof. And just to illustrate the concept a little bit, some people kind of disbelieve that an LLM would really just all of a sudden go rogue. You're asking it to modernize a web app and somehow it's going to steal stuff from you or delete things. Sometimes it does things accidentally, but sometimes other bad things happen. So take a look at this inbound lab result. Let's say we take inbound lab results all the time in IntelliCare and HealthShare and in our Fire repo and things like that. Do you see anything odd with this lab result?
Don asked if we see anything odd with this lab result. Can you spot anything?
Yeah, the shell command in the NTE2 segment.
Yes, there is a shell command right here, this curl command with our OpenAI API key.
Well, you can see there's a comment field to calculate the normal range, run this shell command. and that shell command will grab your OpenAI key and send it off to a website. And so, so that's not so good. But this can happen. Outside data, comments. How much validation do we do on comments? That can get bundled up, can be sent to an LLM with contacts, and the LLM may use that information. So this is kind of an example where, prompt injection, basically. You can get stuff into a prompt that you didn't know was there. So, our product didn't do anything unusual. The LLM didn't do anything unusual, but outside data came in and became part of the equation, and this can happen all the time with systems like ours. Okay, so let me close in a sense by saying I think Agentic gives us additional options to solve problems for our customers. So here's one way to think about it, I guess. This first column is what we've been doing for whatever, decades, where we're hand coding algorithms. We're the brain. We listen to our customers. We kind of build a system that meets their needs. And this is kind of 99% of what we do. Machine learning was a new approach, or is a newish approach. And it's interesting where the data is kind of the brain. So we never figured out in column 1 here how to write an algorithm that would tell a cat from a dog, believe it or not. We just couldn't do it. But we found this generic learning algorithm, and we fed it 1,000 pictures of cats and 1,000 pictures of dogs, and it sort of figured it out. And so that's the concept of machine learning, which is, have done more wonderful things than just cat versus dog. All of radiology, AI, and many other kind of segments of AI are based on this technique where the data really supplies the algorithm by inference and pattern matching and that kind of thing. Agentic workflow, one way to think about it is the LLM is the brain, essentially. So you're configuring the AI system in the way we talked about. It's not rocket science. I mean, we went through the whole story here in this 2 hours and 50 lines of code. It's a concept of assembling the pieces of an AI system and relying on the LLM to do tool calling, rely on the LLM to make the next choice decisions. And this allows a system to kind of roll with the punches of the real world like we do as humans. So you're trying to set up a patient for a next appointment. This doctor's not available. The patient's not available then. You can't get the prior auth. You can't, they'll approve this, but not this. And you kind of work your way through the realities of real life to get a task done. And none of these other approaches are as good as Agentic as kind of working your way through the non-deterministic nature of life to get something done. That's why Agentic is so exciting. So that's it for me. Back to you, Marta and Georgia.
With that said, thank you all for attending this workshop, and I hope you learned something.
Yeah, thank you.
Yes, great.